So what are some of the challenges you see in turning a building's design concept into a durable, high-performing reality, right? Because it's translating design to actual reality. And how can engineers help ensure that buildings meet performance expectations once they're constructed?
We're really evolving in terms of ways that we can verify performance of a building in so many different aspects. It's not just structural, there's thermal, obviously air leakage, water penetration, you get MEP systems, electrical systems. There's ways that we can test and verify these things are working. But, the heart of all of it is collaboration.
Did you know that even the most beautifully designed buildings can fall short of their performance goals once built? Bridging the gap between concept and reality remains one of the biggest challenges in architecture and engineering. Today's guest is working to close that gap. In this episode of the AEC AI and Tech Strategy podcast, we're joined by Ish Keener, SE, PE, and Director of Building Enclosures at Sustainable Building Partners. Ish will be speaking about how engineers can turn design intent into real-world performance, how emerging technologies like AI and blockchain are reshaping the industry, and why quantified building performance is becoming essential to long-term success. If you're passionate about innovation, quality, and data-driven decision-making, this is a conversation you won't want to miss. Before we jump in, I want to tell you about our AEC PM Connect event, where emerging and experienced leaders can learn about real-world strategies to drive performance, empower teams, and lead with purpose. Visit aecpm.com and register today. I would also like to recognize one of our sponsors for the event, AEC IQ. AEC IQ is a service-infused technology platform that helps firms in the AEC industry connect with top-tier, passive talent. Their approach goes beyond traditional recruiting. They find, analyze, and deliver warm introductions to your most sought-after candidates with guaranteed interviews and no hiring fees. To learn more, visit aeciq.com. With that, let's jump into today's episode.
In the AEC industry, skilled project managers are the backbone of success. EMI's AEC PM certification offers tailored training, ongoing support, and exclusive access to premium content that keeps your team sharp and effective. From foundational training to advanced leadership tools, set your team apart with certified growth. Learn more at aecpm.com. That's aecpm.com.
It's now time for our conversation of the week with Ish Keener. Ish, welcome to the show, and thank you so much for taking the time to join us.
Right on. How's it going, Nick?
Excellent. So I know, Ish, you've got a very unique and interesting background, so I'm excited to jump right into it. And let's get started with a little bit of that background. So can you share more about your background and the path that led you to working with building structures and enclosures?
Sure. Yeah. Let's start from the beginning. Grew up in Lancaster. Dad was a residential builder and had some other influences from my uncle, who's a civil engineer, really thrived in the math and sciences. So went to Penn State, just fell into civil engineering. Got my degree in structural design, structural focus in civil engineering there at Penn State. Graduated there in 2009. And then from there, had a cool opportunity. I had a professor at Penn State who got another job out at Missouri University of Science and Technology. So I went from Penn State, went now to Missouri and got my master's. So there I got to do some pretty cool research. There's a private company that kind of partnered with us, got some good funding from the military and we were able to do some research on blast resistant concrete using carbon fiber reinforcement. So that was neat. I got to play a lot in the lab, a lot of hands-on experience there in grad school. So definitely recommend that. But, lived in Missouri. Right after graduated grad school, I worked for that startup that was, kind of developing that reinforced concrete technology. So I did that for about 2 years. And then my wife and I decided to move back to Lancaster, Pennsylvania, where, I was from, and just got a job as a structural designer, traditional steel design, steel connections, a little bit of concrete, reinforced concrete, reinforced masonry, some timber. So I did that for a couple years, sat behind the desk and cranked out spreadsheets and crunched numbers and played a lot in Revit and developed details. And but at that point, I kind of knew that wasn't going to be what I did forever. So from there, I had a really cool opportunity just kind of come up, got hit up by a recruiter. There's a place called architectural testing. Well, it's called Intertech today, but it was architectural testing. It's the world's largest architectural products testing lab. And they had just recently started a building science group that kind of focused on building enclosures. So, when I met with them and kind of chatted about, the opportunity there, I was like, let's give this a shot. Building enclosures, didn't know too much about it. Like I said, my head was, in the structural design world. So I got into it. That was 2016, and just fell in love. It was really cool. Working there at Intertech at the lab, getting to see, how the products that we build with are tested, all the ASTMs and stuff that you see in specs. I got to see, how those came to be. So that was cool. A lot of full scale mock-ups, got involved in a lot of cool projects, learned all about enclosures and building science and, gaps in knowledge in the industry, got into building commissioning, building enclosure commissioning, and we can talk more about that perhaps. But so that's kind of where I'm at. So yeah, I went from Intertech, managed a team there, and then from there, this is about a year and a half ago, started an enclosures group with who I'm with now, Sustainable Building Partners. So I manage a team of engineers and architects that our sole focus is building enclosures.
It's not every day that you really see somebody with the path that you've taken, Ish, right? You get licensed as both a PE and an SE, right? And now you're working in the building enclosure space, which is related, but of course different.
Yeah, it's been a wild journey, going from Penn State and then the economic stuff that was going on in 2008, 2009. So I had an awesome opportunity to go to grad school, took advantage of that, and then just getting involved with the research. But yeah, it's kind of been a windy path as an engineer, but I'm digging it.
And it's all right. And your experience is all about building. So we're going to talk building. So what are some of the challenges you see in turning a building's design concept into a durable, high performing reality, right? Because it's translating design to actual reality. And how can engineers help ensure that buildings meet performance expectations once they're constructed?
Whew, yeah, that's a loaded question and a lot that we could kind of get into. One tangible tool, I mentioned commissioning, building commissioning. That's a documented process that, you could leverage on any project that starts, pre-design, concept all the way through operations. So, I really love going through that process on buildings because you start, with an owner that wants something and needs it to do X, Y, and Z, and they state that up front. You get into design, and then there's feedback, there's peer reviews, and you get similarly then into the construction phase. You have hopefully now a good design that's been, collaborative effort, and then you take that into construction and you carry that through that collaboration. But a big part of it is verification, doing the testing, making sure, shop drawings and, products are going in the way they're supposed to. So there's that effort. And then, the testing part is a big piece of that. There's a lot of, traditionally, from code, there's certain structural tests you need to do, right? Just for safety stuff. But we're really evolving in terms of ways that we can verify performance of a building in so many different aspects. It's not just structural, there's thermal, obviously air leakage, water penetration, you get MEP systems, electrical systems. There's ways that we can test and verify these things are working. So the heart of all of it is collaboration, is the human collaboration throughout that process. So yeah, loaded question, and we could dive into any piece of that if you'd like, but
I'll say, why don't we start with just for anybody in the audience who doesn't know what commissioning is, right? So and maybe an example of some criteria that an owner desires, and then how you actually test for that to make sure they're getting what they paid for.
Yeah. Just to, unpack that a little bit more, commissioning, in human history is just a process to bring something into working order. At the heart, that's what it is. And so for building commissioning, we're bringing a building into working order. But, we as humans used it to build ships. Safety was huge, design of ships, the maritime, it's where kind of commissioning really took hold. And then that got translated into the aviation industry. Again, safety is paramount. And then, that system, that process got adopted by the building industry kind of in the late 80s, early 90s. So it's still relatively new to a lot of folks, but yeah, it's a powerful process.
And so I know for example, for like projects I've been on, like on the structural engineering end, right? Like you had mentioned, say you may test a building for like air tightness or water infiltration given a certain speed of, trying to simulate like wind driven rain. But like any like, is there like a way you could tie that back to an example, something you've worked on or an owner said, hey, like, is an owner looking for like air tightness, or is just air tightness something you measure for another outcome?
Yeah, I mean, owners and what they want is all over the map. I do a lot of, work for institutional clients that care about long-term durability and performance. It's not a quick flip of an asset. So that, they have a better understanding of, I need X, Y, and Z. So for enclosure, yes, air tightness is critical. That's important for the overall energy efficiency, but also indoor air quality. And then talk about protecting the structure. Air brings, condensation, dew point risks, and mold potential. I do a lot of renovation projects, doing one up at Penn State now. They had they're renovating the building, and they had to do a lot of structural steel repair as part of that they just dug into and figured out these issues. So yeah, a lot of examples. But so your original question, tying. So for Penn State, use them as an example in the design phase. So they know they want a certain air tightness. They know they don't want their building to leak. So in the design phase, we're going to come up with a test plan. How are we going to verify that this building is performing? So, we know where the critical transitions are, the window to the wall to the roof, wall to below grade. And then there's just various ASTM and tests you can, pull out of your pocket and just be like, let's use that here to verify the water penetration resistance of this curtain wall assembly, for example. Or let's do an infrared scan, at the end of the project to verify that the roof is watertight. There's a huge range of tools that you can kind of utilize. It kind of just depends on the owner, what they want, what their appetite for risk is, and ultimately what their budget is for it too.
And I mean, like any good engineering project, right? In this case, you're translating the desire requirement of an owner to a finished product through building physics. That's really what it is.
Yeah. Yeah. And then just, earlier talking about what is commissioning. And that's our role as that, the experts, the engineers, the commissioning providers. It starts with the owner's project requirements. What is it that you want? A lot of times they don't know a lot about these different aspects of buildings and construction and what's available to them. A lot of times just like code, just do code, but there's a lot of options above that. So, we help walk them through that. What are some options that we can kind of verify these things that are important to you.
And along with like the actual, right, the steps that you take through design, verification, commissioning, et cetera, to the finished working product, there's, like we always talk about, there's technology along the way that can help you do all that more efficiently or even maybe differently than you would imagine. So there's emerging technology, AI is the big one, of course, which are changing the way we design, build, and manage buildings. So any use cases that you're excited about, and then how do you see them transforming what you guys do?
Yeah, so just to give you some context on my experience using AI, I started playing with it when ChatGPT first dropped, back in 22, and kind of just been tinkering with it as the years have gone on. But one thing I really noticed this year is the speed of the things that it could do. The quality of the responses that I was getting and some of the quality of the models I could tell was improving. So I was like, I constantly thinking how I could use this, just to improve certain aspects of my workflow. But I wanted to pull together some other folks in the company and kind of assemble this kind of AI task force. So that's kind of where I'm at now in our AI journey. We're just tinkering with it, and seeing ways that it's being used in our industry. I think we're still super early, so there's no one tool that I would say like, yeah, go use this, but it's for sure gonna, that whole process from in construction, from design through operations, it's gonna improve every aspect of that process. It's gonna, I mean, you've used it, and I know hopefully a lot of the folks listen to this podcast have used it and kind of understand what I'm talking about in terms of just kind of some of the unlocks in your busy work type stuff. Our goal is to get to a solution, a technical solution that works. And AI have found to drastically reduce that time that it takes me to do that. And then, other folks in our group. So we have, some other, not just Enclosure folks in our group. So, they've been playing with it too and just trying to come up with things. We've been playing with like Replit, trying to develop our own software, seeing if we could create our own tools maybe that don't exist. But, there's a little bit of a challenge there. We've shout out to Sean there at Guild AI. We've met with some AI developers to kind of see what some tools that are out there. But yeah, I think the biggest answer to your question, how do you see it, helping? I think it's going to take efficiencies and really drive efficiencies and drive that coordination that we're looking for.
And I know the way, like I personally like to approach it is, and there's a difference between individual productivity, which I think is talked about a lot more, and then enterprise productivity, which that's a larger effort, because now you have to start thinking about how do you train an entire workforce and equipping them with the tools. And I think for people like us that are really into this or deep in the weeds, using these tools daily, multiple times a day, it's almost like a hobby, or it's easy. But then there's, how do you get the individuals on board that this just isn't really their thing, but it can provide a lot of value to them?
Yeah, there's definitely a pushback, right, to this new tech. Not ageist, but you see a lot of pushback from the older folks in the industry, that I don't want to adopt this tool. What I have found to be most effective is just encourage them just to try it, because I think that's kind of the first hurdle is, folks don't really know where to start, in terms of what it is or what it could do. So, I have a lot of anecdotal stories of folks on my team, that kind of had that mindset, and folks in the industry that I interact with a lot that kind of had that response when I ask them, have you tried any AI yet? And I get that response. It's like, well, let's download the app, let's just give it a try. And then the response is always like, I should have done that sooner. This is really cool. So that's why I appreciate, you getting the word out. And like, that's why I try to spread the gospel there, tech gospel as much as possible, because it is such a powerful tool, and it's going to continue to evolve and, really change the way we design and build.
And I think there's always going to be example use cases. So anything text-based is great for an LLM. So in the case of, let's just say, building science, right? So reports, specifications, emails, project meetings, right? Which easier said than done. You actually just have to go out and try it. But I think the enterprise value gets unlocked when you start to understand what your business's specific pain points, bottlenecks, etc. are, and then bring in the tools to help solve them. I think you hear a lot about the tools, but less about the strategy. But I think that's up to each individual business to figure out.
Well, yeah, no doubt about it. Each individual business needs to take into consideration all of that. And this stuff is being built right now. Like, there's no one solution right now that any company, I don't think, could just widely adopt. I think every company is a snowflake, and then they're gonna have to kind of figure out what works. And that's a get back to the experimenting. Like, if you're a company out there and you're not experimenting with it, like, it's to your point, it's not just the technical part that you and I do day to day, but it's the marketing and the financials, and how it can help with all the overhead tasks. And
and just in the business, the type of business that we live and work in, even just say 4 hours a week per person would be huge if you could actually eliminate. Now, what you do at that time is a different discussion, but
well, you just solve the next problem.
Exactly. And in terms of so how do you make money as a firm? Well, if you can reduce that 4 hours of time of overhead tasks, that's great. That doesn't net you any more money. But if you can even turn those 4 hours of overhead into 2 more hours of productive work, and then jetting out 2 hours earlier, but I think that's what each firm just has to go figure out for themselves based on how their specific business functions.
Yeah, I mean, it's going to change that dynamic for sure. I mean, we talked about this when we went out for happy hour last time, a few months ago. But, not just the overhead stuff that you can reduce the time on, but your and I time that, we could traditionally bill for, a 10-hour task is now taking an hour. How do you bill that?
Yeah. If you,
I mean, it's a value proposition. I mean, so you got to make a really cool deliverable. You got to make a deliverable that, the client can digest and make
what
sense.
if like you guys build something in Replit and let's just say it cuts down on a shop drawing review by 25% just because
I
you've
have so many examples of things like that. Yep.
and you figured it out for yourself. And now you start the discussion of, so how do we make money? What business model do we employ? And then how does AI or other technology change that business model?
Well, I think it's the same business model because you're still delivering the same thing at the end of the day. It's just a solution to the client.
Mhm.
So I don't think it matters how you arrive to that solution. I don't think they care. We're using AI, it's dropping our man hours, but I don't think that means you pay us less for that
And
same amount of value.
yeah, and I would tend to agree. Now the pushback from, let's just say, firms that are more traditional in the way they think is, well, if I can't bill for it, I can't have my people spend the time on it. How do I not lose that revenue if all I'm doing is on an hourly structure? And by business model, I meant, well, for certain agreements, do you just go to lump sum versus an hourly? And how does that change the way you operate your business?
I mean, that's the evolution that's going to happen over the next couple of years that businesses are going to really need to figure out, and it's going to happen quickly. So that, they're going to need to adopt and it's not just about, keeping people busy for a couple hours so you can bill it. That can't be the mindset.
And then from that to recruiting of you as like a young engineer coming out of school look and say, okay, like I've interviewed at 3 firms. One is like relatively stale, but not super interesting. Another's like your average run of the mill firm, and then another's really like taking initiative to train their people and help them understand what these emerging technologies mean in the context of them being a professional, right? I don't think rewinding the clock for me a couple of years when I was coming out of school, if somebody told me I'd have to just sit and make busy work just to be able to build time, it's
flat, right?
Yeah, it's a terrible proposition.
No doubt about it. People, young folks, I think it's not just young folks, but people want to understand why they're doing what they're doing, and they know when they're just doing busy work, if they have a solution that they could get to the solution and they know they could get there quicker using X, Y, and Z tool, but their manager won't allow it because, for whatever reason, because they need to be billable. They're going to be like, yeah, and get me out of here. This is dumb.
And my first role out of college, I was trying to tinker with software that would ingest drawings in any form that weren't vectorized, essentially, so not DWG files. And the idea was that instead of our drafters tracing, we could just feed it and then get like an 80%, which then the drafters could clean up, saving time. Well, it was shot down by my manager because of exactly that. If we can't bill it, can't make any money on it.
Hate hearing stories like that, but yeah.
And I don't necessarily blame those people because their incentive structure is very different too, because they're incentivized to make the company money today, unless the company is forward thinking enough to say, hey, like we understand what's coming, what's changing, and part of that is a change in the way we do business.
Yeah. And I think what I'd like to say to every company is get there as quickly as you can, because it's coming.
And the beautiful part about it is if you start, and all of our jobs are run on a lump sum basis, so we just don't bill by the hour, but you can see on paper how the things we do from an innovation standpoint make us more efficient and how that ultimately affects the bottom line financially. So
yeah,
but And the theme of just also getting exposure to this industry, because you and I both know it's a great one to be in, but it doesn't get as much attention as it should. I want to explain the difference between engineering for existing buildings versus new construction? And then what types of insights do you guys gain from forensic or retrofit type projects? Because actually, like you're probably one of the few, right, who head down for years in the structural design world, and a lot of what I would assume is new construction. And today, a lot of what you do is a split between the two,
Yep.
new and existing.
New and existing. Yeah, and definitely being involved in one is informed the other, and it does every day. Yeah, when you go into a renovation project, you need to understand your current conditions. So forensically, how you approach that, what are the existing conditions, performance, what is your current performance, maybe your MEP systems you need upgraded, or upgrade the looks and the roof. But you need to, before you go into design and figure out how to achieve that, you need to know what your existing conditions are. And so that's where forensics is very powerful. So, getting into your wall assemblies and making sure you know what the existing conditions are. Even if you have a set of existing drawings, you and I both know that you look at those drawings and that's not how it was built,
Mm-hmm.
95% of the time, right? It's like,
There's always,
it's, I mean, going to be, so you have to, forensically, get into it, figure out what your conditions are, and then carry that information, that data with you into the design.
absolutely. And from a structural standpoint, for example, right, if you are trying to, let's say, change the use of a building from one that's popping up more and more, it's like a parking garage, to residential, well, that's an entirely different loading scenario, and like 2.5 to 3 times live load depending on what you're dealing with, right? So that's one example. And then from the enclosure consulting, right, I mean, I'm sure you can offer a number of different use cases just depending on how, right, the HVAC systems in the building interact with the existing conditions, and then ultimately, like, let's say your wall design and how you're thinking about how the whole system's operating.
Yeah, what kind of insulation you need, what's your current air leakage performance. There's a lot of great information you can glean just by putting in a little effort up front.
And I think that's a piece that's underappreciated, like in the existing structure restoration forensics world, just because, just by quantity, there's, right, what do you hear about on there's new building, right? 50, 100 billion dollar projects. That's not really what we do, right? I know, like, our average repair project size is like in the 6 figures. These aren't huge, and they're not gaining a ton of attention, but they're really important because it teaches you a lot about the different types of engineering that goes into it.
Yeah, no doubt about it. And you get to see the failures, the things that work and don't work, how do we evolve and make our design and our practice better. You learn all of that through seeing what they did 20 years ago. Let's do it a little bit different today.
And another one of my favorite parts too is, like, from the AEC technology space, there's a lot of attention and a lot of capital going into solving the problems of, like, big general contractors, big engineering firms. There's not quite as much invested, I would say, in this space that we're in. It's kind of like a smaller pond, which is exciting because you can be the one.
The restoration space, you're saying?
Exactly.
Yeah, forensics. Yeah.
Because you can be the one to, like, develop stuff internally for your own firm, or partner with a startup because they have an idea that aligns with yours. So I think it's super exciting. It's just about finding, for anyone who's, like, considering joining and listening, it's just about finding the right team to actually be a part of.
Yeah, no doubt about it. You need to have a goal going into it, know what you're looking for.
And on that note, I mean, this has been great. It's always great to talk to, somebody who's not just in the industry and focused on tech, but in the same niche and vertical. But any final piece of advice you'd share with other professionals, particularly younger ones who are, either coming out of school, or they're in our shoes and are just trying to navigate the amount of change that's going on right now?
Yeah. I figured this question would be coming up, but put yourself in uncomfortable situations. Make yourself feel uneasy at times. Ask that question in a meeting. If you don't know something, or assert yourself. But I think that's how you grow as an engineer and how you learn. Is just kind of be uncomfortable. And as engineers, traditionally we don't like to do that a whole lot, right? We like to kind of just hang out in our cubicle and do our thing. But that, and then emotional quotient, figuring out human coordination, how to communicate, writing, technical writing, how to get your message across. But those are all, we talk about AI and the things that they're going to be able to take away, but they're not, that's a skill that every engineer is going to need to have. So I would sharpen that tool.
Yeah. And you've said it well. And just, to add, it's anything that, as long as humans, right, we build for humans, we sell to humans, built by humans for humans, there's always going to be that element of being able to have a skill set that's just not easily replaced by technology. I think is going to go a long way. It's just a general principle, but
yep, no doubt.
And Ish, it's been a pleasure getting to catch up with you again. If the audience has questions for you, wants to reach out and learn more about what you're doing, what's the best way for them to connect?
Hit me up on LinkedIn. Ish Keener, ISH Keener, Keener. Yeah, find me on there and let's chat.
Beautiful. So Ish, again, it has been an absolute pleasure.
Right on. Thanks, Nick.
You got it, Ish. Take care. Please remember, you can find the show notes for this episode at aectechpodcast.com. There, you will find a summary of key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, I wish you the best in all of your engineering and technology endeavors. Thank you.